Good day to you from Anna Galactic on this 5th day of March. That was the lab cat achieving her perch. If you're tuning in for the first time, you're in very good shape here as far as the series goes. We are achieving synthesis on the most difficult problem ever to face physics. That would be a multi-step project to get to the solution for that by anybody's standard. I've taken about 450 steps in these presentations, considering the presentations one at a time, but now we're achieving synthesis and we're resynthesizing a new definition of time. It turns out that we have been able to locate the source of the difficulty in perceiving what the quantum paradox means in any sense. Now, we do deal with mechanics in science. You've certainly become well acquainted with mechanics. In some sense, it's considered to be identified with science, and if you're choosing that as an orientation, it's identical with science, and that is insufficient for describing reality. You also need a province of science that's fallen out of vogue, but it's coming back into vogue, in fact quite rapidly, called natural philosophy, which can be characterized in different ways, but the way that we tend to characterize it in this dichotomous approach, which is a natural approach, a binary approach to get some grip on reality, when you adopt a mechanistic point of view of the universe, you've left out the best part. And this comes up in several ways, and it is a philosophical issue, and it, of course, as with anything else human at this level, it's violently, violently emotionally contested, as if life and death were dependent on your orientation towards a mechanistic universe. What is mechanism? It is a scientific principle, obviously. It's based on causality. That when something happens, then that is the precursor for something else to happen. It's really that simple. That things cause each other. And probably the best way to visualize this in order to have a substantial visualization of what is mechanics in science, picture a clock. Picture a watch. Picture the workings of the gears. Once you have completed your timepiece, either in Switzerland or however you're making your timepiece, you set it in motion. And when you do set it in motion, depending on the source of the continuing cause for the motion, we would call that energy. You are adding energy to the system. But once you've set up your circuit for the continuous injection of energy into your clock, it ticks by itself. And that's the mechanical conception of the universe, that it is nothing more and nothing less than a timepiece. It's nothing but a clock. It has no soul. It has no originator. There's nothing you can say about it, except in a mechanical clickety-click sense. So what does that leave out, if anything? It's easy to overlook this, and it's even easier to misstate it, what you're leaving out completely. When you are talking about mechanics, you're talking about event sequence. And so you're speaking temporo-spatially, space-time. The province of space-time is where things happen. It's the arena. Well, the arena is not the mechanism itself, it's the backdrop. We call that space, or we call it space-time, or we call it infinity. We just say that it's a vacuum, or it's just void, or it's, if you're insisting on it, everything being mechanistic, you might say it's a flux. That's a quantum field theory extended to rather bizarre proportions. But that is the essence of mechanism. Absolutely fundamental to physics. Is there anything else that is fundamental to physics? If you don't get the answer to that question correctly, you have zero proposition for understanding the quantum paradox. Because as Bernardo Kastrup has pointed out, with many predecessors before him, if you attempt to understand the quantum paradox, insisting on a mechanistic approach, such as Tim Maudlin does, you cannot get the answer. You will not get the answer because you're not a real scientist. And that's when you put on the gloves and you start fisticuffs, because men have proven and continue to prove they will fight to the death over this issue, which is the question. It's the ultimate graduation test question. All your dissertations, everything, all your A pluses that you've gotten along the way mean nothing unless you get the answer to this question. It's like being branded at Shaolin like Kwai Chang Caine was in Kung Fu, a very nice TV show. This is the acid test for what you are as a scientist. And what is my question to you now that determines whether you're a scientist at all or just a goddamned fake? Besides mechanism, mechanicality, mechanics, besides that aspect of science, what's the other aspect of science that makes science whole? There's only one right answer, but it can be stated in at least 4 ways. So you have some scope for getting this answer correctly, to get this answer right. What is it that balances mechanistics that makes science, and without which you have no science? I'll give you a multiple choice question so that you can attempt to answer this and at the same time divine what is the possible scope of the answer, because that's rather abstract, isn't it? I could be speaking at many levels, and perhaps it's hard to disambiguate what I mean. What is the balancing aspect of science that completes science that's not mechanism, that's not mechanistic? You could say mechanicality. The mechanistic approach to the universe, when it's forced into a box so that you must interpret things mechanistically when you have, for instance, a paradox or an unsolved question, and now you have to theorize, as you do when you go back in time to get your origins, for instance, or when you extrapolate back in time to get the origin of the universe, for instance, or when you extrapolate to the center of things to get a particle model, a cosmological model, or a model of ecologic origin. You have to extrapolate. And if your guiding principle is mechanistic, you get the wrong answer every time. It's an edge problem in which this mechanistic conundrum comes up. So you must be able to answer this question, or you cannot be a scientist, because you'll always get the wrong answer. That's hotly contested, and that can be violently argued with. Tim Maudlin would definitely argue with me. He would say, no, it's mechanistic, because physics is mechanistic. There's no other aspect. If you're in the dark and searching for an answer, to get any one of the 3 main models. In all 3 cases, the models that dominate science now are mechanistic, completely mechanistic, and they've scrupulously overlooked the anti-mechanistic side of science, and therefore we have 3 outrageous models that are completely anti-scientific. And therefore, you and I are affected by the condition of science right now, because we're not allowed to know our origins, we're not allowed to know anything about the universe that makes sense, and we're certainly not allowed to know about the building blocks of the universe, because everything's mechanistic. And if you try to describe things like the human condition in any way, consciousness or purpose, you can't get anywhere, because you're dealing with mechanisms. And you will interpret everything that way. That's been demonstrated. And if you go along with any one of these three models, you are not a scientist. You're an anti-scientist. So this is severe in the extreme. So what's the answer? Let me give you some choices and you can choose more than one. Geometry, structure, motion. I think you understand all those are correct answers. It's geometry and structure. You could say either one. They're synonymous. Almost synonymous. They do have slightly different nuances. But that's what's missing. And that's a major insight that you have to grasp. You have to master this. And I mean right now. And I don't care if you already think you've mastered it or you have some better answer than me or you want to talk back or cavil. Put that all aside and look up, pay attention, get your fucking brain screwed on straight, and answer the question directly, because everything depends on your answer. What is the other part of science besides mechanics? It's geometry. Because geometry is not mechanical. Well, that's not the part of the reason for stating it that way is structure is the universe. That describes the universe. Does mechanism describe the universe? Of course it does. So is there a contradiction? No, and that's the synthesis that you need to achieve right now. Is that mechanics is always geometry. Everything is geometry, but not everything is mechanics. Because you could have a clock without any energy, and it just sits there and does not tell time because there's no energy to make the clock move. Correct? This is very profound. That in order to have motion, time, angular momentum, you need energy. And the universe is said to be made of energy. Is that considered to be mechanistic? You can take a mechanistic approach at any place in science. The only question is your mechanistic solution going to be complete? Will it be complete? You won't be able to complete a closure on a system unless you identify the structure. It's really so simple. It's very obvious, but it's incredibly overlooked, denied, and fought over. Tim Maudlin and Bernardo Kastrup are excellent examples of this confrontation because they tried to claw each other's eyes out like little schoolgirls over this exact question that I'm asking you. And so your soul as a scientist is on the line here. Do you take Tim Maudlin's side, that the answer to the quantum paradox is going to be mechanistic? Or do you take Bernardo Kastrup's side, which the answer to this quantum mechanical paradox is not going to be mechanistic? Well, if Bernardo is saying that, which I am telling you he has every right to do, then what is he offering instead? Here's where Bernardo Kastrup slips on a banana peel and lands on his ass when he had a chance to be the hero. Because in order to overcome the quantum dilemma in the scientific mind somehow distributed among us all, the major glitch is not on the philosophy side. That's virtually lacking. And it is philosophy if you think of philosophy as geometry. Your philosophy has got to propose a physical model that has structure, relationships, and a geometry. A geometry. What is a geometry? It's a structure that has relationships that you can see. This is the tremendous failing, one of the major failings of Einstein's space-time formulation. is that it is impossible to visualize. There is a geometry, but it's so extraordinarily convolute that it literally cannot be perceived by the mind of man, with a footnote that Einstein could perceive it, or he could not have formulated it. And to a certain derivative extent, future scientists following Einstein have been able to visualize it somehow, or they would have no understanding of it whatsoever, because that's the definition of understanding. A mechanistic solution never includes understanding. The understanding in a mechanistic solution comes from the non-mechanistic construction. It's the structure that gives you understanding because you can see it. So, where we got to yesterday is that we discovered an unseeable dimension. This is what was sought. So that part of the answer to the quantum paradox is to begin with structure and to deduce carefully from the paradox itself what is the structure that we are failing to see. We are not seeing the structure. We have no geometry for the quantum mechanical phenomena. No structure, no geometry, no visualization. It's much worse than space-time, where at least there's an involute, convolute. Those are probably the two best characteristic words for the time-space formulation. It's an involute, convolute monstrosity of twisted lines. But it still has that geometry. No matter how convolute or involute it is, it can be deconvolved and de-involved in order to see it with a space-time projection to 3D showing a light cone. And so there is a geometry called pseudo-hyperbolic geometry. So space-time works to that exact proportion that the geometry is correct. Now, when we turn to quantum mechanics, which we want to unify with general relativity, that is the goal right now. The solution to the quantum paradox will be to unify quantum mechanics with general relativity. So, what's missing in quantum mechanics, if that's where the missing part is? What is definitely missing in the present formulation, both of space-time and quantum mechanics, is that in space-time you have a pseudo-geometry, which counts, but it's horrifying. Calculus is unbelievable. And the geometry is, I'll just say, extremely difficult to visualize. But in quantum mechanics, there's no geometry. There's no formulation of structure. That the paradox is the missing structure. So that means that the solution is geometric. And the way we began yesterday to penetrate the paradox using this approach is to examine the quantum entanglement experiment, just exactly what's being done. The two particles are in close proximity and they're coordinated. They're mechanically coordinated. That's an action you take on the two particles to coordinate them. Once they're coordinated, they're in a known state. But you can see what you're trying to do is separate the states to see what happens when you separate them. When they're entangled, that means coordinated. So the two particles are coordinated in an entangled state. The entanglement refers to the logic involved. But the right word is coordinated because that's structural, for Christ's sake. Entangled means you're never going to understand it. You just use the word for non-understanding. They're entangled, well then they're jumbled. You'll never figure that out. But if they're coordinated, which they are, then you have a structure. How are they coordinated? They're coordinated on a specified state which is known. And that's abstract, but this has been done in several ways. Once they're coordinated, they're virtually the same particle in the sense of having an event characteristic. Now they have an event characteristic that's coordinated. And now you separate them spatially to see if they'll remain event coordinated. They do. And that's considered to be a violation of relativity, because you cannot have spatial separation without a time separation. And when the two entangled particles are measured, it's very difficult to do, but it has been attempted many times with increasing success in the direction of proving that when the two particles are spatially separated, there is no event separation. And that means that time is in another dimension. That's exactly what that means. And that is it's partially spatial, but now what's the other dimension? What would you call it? What Einstein called it, and what his predecessors called it, when they referred to it in any construct or sense, they referred to it as the time domain. The time domain. Now, why don't we use the word dimension? We could, and I will, but it's in a different geometry, because the only concept we have of dimensionality, and therefore of domain, is linear. And so linear 1D is the 1D domain of the linear systematic space. And you can say that because of orthogonality. You can have two lines in a specific relationship that are balanced. And that's called flat space. And then if you add depth with a third orthogonal line, you have volume space that's cubed. It's cubed volume space on a linear construction. Okay? So, we conceive of space in terms of linear dimensions. But time cannot be so considered. It's in another dimensionality. It's not in a linear formulation of dimensionality. It's the other geometry that has been so amazingly overlooked. We discovered that the universe is spherical in the 20th century at every scale. But since then, we have not been able to adjust our mathematics to that discovery. And so we continue to refer to spatial separation on a line. Now that makes sense to us, and as I said in the last lecture, that is best considered to be inviolable. But you're looking for something that needs to be violated, because we got something wrong. Well, where did we go wrong with space-time? Wasn't with space. Because linear spatial separation we fully understand. But sphericity we've never understood. And there's a characteristic of spherical dimensionality that includes something that linearity cannot include, which is a rotary concept. And you notice that whenever I do this on the circle, which is the equator of a sphere, I move my finger. That's because space doesn't move. And so whatever is happening on the sphere, again, is happening in a different dimension. It's this that's happening in a different dimension. It's the repetitive cycle of the closed line, manifesting something that's difficult to describe, so let's describe it to see how far we get. And just to give it away, you're essentially going to be describing the electron and the photon at the same time. It's centrifugal force. Centrifugal force. When this happens, my finger is trying to fly off on a straight line at all times. And that's called angular momentum. Well, that's not spatial. You know why it's not spatial? Let's be sure we understand why this is not spatial. Because you can see that it's happening in space. You can see it. But what is it that you're looking at that's not happening in space? You have to put it another way to see this clearly. What can you do on a circle that you can't do on a line? This. You can't achieve closure. This is a closed line. Correct? It doesn't go off to two infinities. It doesn't go off anywhere. It stays where it is. It stays in the spherical realm. On a circle, this is the equator of a revolving sphere. Well, this is a click, click, click. These are events. Click, that's not spatial. Click, click. It's happening in space. Well, so's the electron. So's the photon. They're happening in space. But what they're doing is not happening in space. It's happening in the temporal domain. Because this click, click, click is happening at the same place every time, but the same place every time is the entire sphere. The sphere is a unit. It does everything that it does it at the same time. That's a very, very profound insight, if you can mull that over in your spare time. But I trust that you grasp that. But if you do, to the proportion that you do grasp that, you're grasping the solution to the quantum paradox right there. Because this click, click, click is happening in this dimension that's not linear. It doesn't move. The sphere itself does not move through space, but something happens in its space. That's locality. That's the locality of temporality. That is the location of time. Energy can only be measured in time. Motion can only be measured in time. Spatial separation is not measured in time until Albert Einstein came along and said that when you measure spatial separation, you're always measuring a temporal separation. That has been disproved. And that's where Einstein's relativity shows its flaw, is it does not deal with sphericity, and that's the missing geometry. Because to understand this click, 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 in a space that's closed but does not move, that is, to do what it doesn't need to be moving. It itself is manifesting motion. Well, that's in time. So what's the relationship between time, motion, angular momentum, and energy and centrifugal force? These are all related on the sphere. Okay, but they're not related in space. They're only related on this click, click, click motion. The repetition of an event. Okay? Now, we also discovered, by extrapolating on that the flight of the photon is absolutely described and the collapse of the wave function is no longer a mystery. So we have part of the solution to the quantum paradox, so let's be sure we recapitulate that so we have a firm understanding of the first chink in the armor of the quantum paradox, that we got part of the solution, because we have a principle now to work on, spherical geometry with a temporal domain, that explains the collapse of the wave function this way, that when the photon is in its space flight, going at the speed of light through space, we measure that on a straight line, because that's the result of the spatial separation of the photon from its origin. When the photon leaves its origin, its flight through time and space begins, right? And we call that space-time. So it's covering time in proportion to the space. That's well known. That's why we have light year measurement, and we have to use a year in order to describe these long cosmic distances, is because the photon is traversing time and space. But it's not traversing time in the same way that it's traversing space. But we measure it as if it were traversing time in the same way it's traversing space. It is not doing that. And that is the solution to the photonic form of the quantum paradox. And now we're going to solve the collapse of the wave function to get the first ever visual representation of the full flight of the photon. That when it goes out, we know that it's in waveform. That's well known. And so the paradox is that it magically turns back into a particle when it reaches its destination. And the question is, how does it do that without violating space-time? It does so, and it does not violate space-time because space-time was formulated in a way that makes it impossible to see the geometry, because it was composed purely in linear geometry, which does exactly cover up the sphericity. Sphericity does not appear in the Einstein field equation. It induces a spherical function in the 4D field, but it does so with it's the equivalent of complexity, that is, the use of an imaginary space. Time is imaginary in the Einstein field equation. Imaginary here has a mechanical, not mechanical, but mathematical meaning. It doesn't mean it's not real, although actually it does, because you're not seeing the full extent of the reality of what's going on because you can't see the spherical physicality. And the spherical physicality is inherent in the photon. It is a spherical phenomenon. To be a particle, it would have to be a sphere. If it's consistent, if it is energy, and so we know that it's spherical. But it doesn't have the same locality that a proton does. A proton has a physical center in space. A photon does not, and it proves that on its flight. But what is it when it's flying such that it could magically become a particle again? There's only one way it can do that, and we discovered this from quantum mechanical investigations. It's superposed on the sphere, that the photon is on the sphere. That's tautological, and that's basically the pilot wave construction, that even though it's a wave, it's still a particle. Now, we've always considered that to be the heart of the paradox because of the wave-particle duality declares that something cannot be both a wave and a particle at the same time. But if you begin by asserting that it has to be both at the same time, you can force the solution with a visualization of the geometry in which that would be true. And that is spherical geometry, but you have to do it right. This does have to match physics. We're not going to make up anything that violates physics. We're actually constructing the geometry that explains physics into a threshold that physics has never been able to explain this. So let's explain it. The photon remains a sphere, and as it propagates through space, it does not change. And I think that's a one good place you could jump in and bend your mind to see that it just simply doesn't change. But something is new that nobody's been able to see that you and I are going to be able to see right now. It's this, that the photon is superposed. It's a superpositional phenomenon. It's physically superposed. It's not mathematical anymore. It's geometric. That photon is literally everywhere on the sphere. Now there's a footnote to that. This has to do with a data type of temporality. That how do we actually measure time? Do you know? The second is based on the solar year. I think if you're not fully aware of that, you never heard it said that way, you could instantly concur, logically. Well, that's a circle. And so time, we do conceive time to be part of spherical geometry. That is how we compose the second. But then we linearize it, don't we? Why do we do that when that's obviously a mistake? According to our approach, that would be a mistake to linearize time. It's because time is linear when you derive it from its true origin. So what is the true origin of time? Click, click, click on that sphere. That's time. Its time is going in another dimension. It's actually going. But it's not going anywhere. It's going around and around and around. Well, what is that? It's the manifestation of time. But time itself is not this. This is not time. This is a spherical function of motion. We call it energy, so we do know what this rotary thing is. We have all kinds of names for it. Angular, lots of things. Angular velocity, angular frequency, angular momentum. Other words come into play that don't apply to space. Periodicity, frequency, and wavelength. None of these are spatial. They're temporal. They describe the click, click, click on the sphere. Well, that's a different dimension with a different data type from which we derive time. Time is the linearized component of a spherical propagator, but it's not spatial. And so when Einstein coordinated space and time, that is time-space, the coordination of space and time geometrically, it is correct in the sense that you've used a derivative term, which is time, to correspond with another derivative term, which is linear space. Linear space does not exist. It's a derivative of real space. So linearity is artificial, but you can use it and compute it. It's real in the mathematical sense that it's part of the linear system. And a straight line distance to a star is described by the flight of the photon. There's no way around that. But the magic is that photon goes straight. Well, it's going straight through space, but it's not going straight through time. Actually, it is. In the construct that we use for light speed and light years, we're correlating to linearized functions. The functions themselves are not linear, but the derivatives are. And so linear distance is a derivative of spherical distance. That's true. I proved that in 2022. And time is also a derivative, but not of anything spatial. Time is the derivative of angular momentum, and distance is the derivative of sphericity. Spherical space. Spherical space dimensionality can be derived to a straight line. That would be a line of force, where the force is spherical, but the line of force is derivative. Time is very similar. Time is the result of angular momentum, another spherical function. Space is spherical when you derive the straight line for that construct. It's a derivative of spherical space. I proved that. Time is the derivative of spherical momentum. And that's the difference between matter and energy. So this is synthetic to the utmost degree. Now for the paradox that baffles the you-know-what out of everybody who's ever faced it, including myself. The photonic, which we're not saying is a particle or a wave, because no one can actually say what it is when it's in space, although you and I will see it presently. The photonic goes out, and it goes out from its source. So it's increasing a linear separation from its source. That's what we actually measure. We measure the linear separation, although the photonic is not going out in a linear direction specifically. It's going out in an integral of linear direction called a spherical direction, and that's called a wavefront. Now when it arrives, it simply reverses that. Only it has not seemed simple. Let's simplify it, because that's the essence of science. When the photonic, which is nothing we've been able to describe, it just is, and we can retroactively say what it was. But when we do that, we can say it in two ways and have to say it in two ways, and we can't reconcile that the two ways are the same way. So that's the paradox of the photonic, that it's traveling in a form that it simply cannot travel in. And we can't define what it is. That's the paradox, is the propagation of light in space. It doesn't dissipate. It reconstructs itself absolutely on arrival, just as if it had never changed from being a particle form, except that it never did change from being a particle form. So that would be a partial solution if we can justify that statement. Here's how you justify it. when the photonic arrives, it arrives as a particle, plain and simple. Well, then you're forced to say something new about the flight of the photon, that it never changed state. It's always a particle, and that's it. That's the answer. It's still a particle. So where's the paradox now? The paradox is that the photon particle is everywhere on that sphere at the same time. And that's called superposition. And the fact that the reason we can state that that is totally entangled is a fully entangled state. It's superposition, supercoordination in event space, which is spherical. But it never loses its sphericity. We can extract the linear component of the photonic after the fact, because we can see where it came from. It's telling us where it came from. We are looking at it, pointing our telescope at that light source, and therefore that's a straight line to wherever it was when it released the photon. And that's a true and accurate representation of reality. Light captures reality, it brings it to us, and then we see the reality that's in the distance and reconstructs it perfectly. An enormous amount of information is locked into light. I don't know if you're fully aware of that. I trust you are, so I won't elaborate on that. But the arrival of that photon is the arrival of a library of information. So how did it maintain itself? It didn't need to. The photon does not change. It virtually goes straight to your telescope. And the reason it can do that is that it's everywhere on the sphere at once. That's called superposition. Now, the baffling part, which we've gotten to in part, is that the reduction of state clearly violates special relativity. Now we indict special relativity because we know we can see what's happening, and the only glitch was in our presupposition that event space is correlated with spatial space. Is it? Yes, but not in the way that Einstein formulated. Because he coordinated two derivative numbers. That means you skipped something. You're coordinating two derivatives? Wouldn't you rather coordinate the integrals? Of course you would. That would be reality, what's actually happening, not a derivative. A linear measurement is a derivative measurement of spherical reality in both cases. Because space is spherical, we know that from gravity. Is time spherical? Yes, it is. They're both spherical. And they manifest perpendicularly. Einstein did discover that. And we're coming up on 45 minutes. I hope that this presentation helped you to solidify your view of a new geometry called spherical geometry, which I discovered. And everything that I'm telling you is retroactive and retrospective. I fully and completely understand quantum phenomena now. And I can safely say that I'm the first man to do so. And if you think that I'm just like sitting on my laurels and saying I got mind mate, you got another think coming, because no scientist thinks that way. My work has just begun. I am now capable of answering a whole list of open-ended questions in physics right now. So that's what you're going to be able to do too, so I hope you tune in. This is Anagalactic, bringing you the secrets of the universe now. One of the key ones, the one we all want most. Nature of light, nature of energy, nature of matter, the relationships between things that describe physical phenomena in a way that's not purely mechanical. You have got to see the geometry, or you won't see. It has to be demonstrated mechanistically, but that could mean that you need to change your existing view of mechanics. Einstein, field construction is a derivative solution, and therefore it missed reality. And that's why we're stuck. It's because of Einstein, who got us one of the greatest tools of the greatest importance, certainly for spaceflight. We wouldn't have GPS, we wouldn't have spaceflight. We would have no outer space capabilities without relativity, so it's worshipped. Well, you can't do that in science. You can't worship your model. Your model is a tool, and you're finite. And if you want to get closer to infinity, which in this context would be like God or the ultimate, we want the solution. We want the rational explanation for the universe. We're going to get it. I got it. To a new threshold. So stay tuned and don't forget to keep looking up. When the skies part at night, take a look. You will never regret doing that. You may even become religious. This is Intergalactic, bringing you the secrets of